Okay, so as promised, we're going to do some more difficult applications and examples. The application or the example I want to do is this. For this up here, section of a circle, arc of a circle, hard to see, but that's this piece right here, arc of a circle. Let's throw some dimensions in there. They're going to be in millimeters. Obviously, this is not drawn to scale. I'm going to need to give a radius for the circle. I'm giving you the radius and not the diameter this time. What we are trying to find here, this angle x. Well, the tricky part on something like this is finding the desired right triangles. So where x is there, I would have a hard time drawing a right triangle. There really isn't anything there that's an obvious right triangle. The one obvious right triangle in this drawing is, if I take from the center of my circle out to there, where an arc becomes a straight line, it assumes that is the tangent of that straight line is the tangent of the circle. That's a right angle, so I can connect that center for that corner and make a right triangle there. That's one of the more obvious ones, or the easier to find ones. But looking at that, the only dimension I know on that, this is 50.18 millimeters here because it's the radius of the circle. I don't know any other lengths. I don't know any other angles other than the right angle. So I need to find another triangle. Well, right here, that's a vertical dimension. This is a horizontal dimension. That's also a right angle. And for that one, I can find one of the sides. I can find two of the sides. Let's start by finding this side here, which I'll label side A. Noted, this dimension here, from the center of the circle up there, is just a radius of the circle. That's 50. So to find A, 306.08, that full height, subtract each of those three dimensions. So let's subtract the 50.18 first. 5.90. Then we'll subtract the 47.39. Giving us 208.51. And then finally, I'll subtract the 92.37. Giving me with 116.14. this dimension here, which I'll call B, a little simpler to find. How do I find that one? Perfect. 282.43 millimeters minus 152.50 millimeters. Giving me was at 129.93. So let's redraw that purple triangle here. I have 116.14 over here. I have 129.93 down here. There are two pieces of information that I want from that triangle. I want to know this angle, and I want to know the length of this side. That would be this angle, this side. For the angle, .116 would be which side of that triangle according to the angle? The opposite. 129 would be the adjacent. What trig function uses opposite and adjacent? Tangent. Tangent of an angle. The opposite side divided by the adjacent side. So I don't know the angle. That's what I'm looking for here. My opposite side is 116.14. My adjacent side, 129.93. How do I find the angle? If I'm looking for the angle, I have to get rid of the trig function. How do I get rid of the trig function? Inverse trig function. Inverse tangent, 116.14 divided by 129.93. Second tangent. Right. 7294. Obviously, that means I am in radian mode, not degrees. Let's try that again in the right mode. There we go, 41.79 degrees that gives us. Write that in up here as well. I'm going to need that. The side is a lot simpler to find. Find that side, it's simply the root of 129.9 third plus a squared plus b squared equals c squared. That's 174.27. And I'm going to write that in up here. So now I need to look at this triangle. Draw it in green. That green triangle there. I'll redraw down here. I know this is 174.27 millimeters. We just found that. I know this is the radius of the circle. or 50.18. There's only one piece of this triangle that I'm worried about, that I want to find. This angle down here. How am I going to find that angle? 50.18 is which side? Opposite. The 174, it touches the angle, but it doesn't touch the right angle. It's the hypotenuse. So it is what trig function? Sine. There we go. Sine of an angle equals the opposite side over the hypotenuse. Here we do not know the angle. That's what we're looking for. Opposite side is 50.18, and the hypotenuse 174.27. Now, I've said in the past we try to avoid reusing dimensions that we've calculated ourselves. Here we just don't have a choice. We have to use that dimension. How do I find the angle here now? Inverse sine. Good. .18 divided by 170. We're at 16.73 degrees. That's this angle right here, 16.73 degrees. So we draw that little piece there. Here's angle X. But I know I've divided this angle over here into 16.73 here and 41.79 over here. I know that this has to be add up to a right angle, so how am I going to find angle X? Got it. 90 minus, I'll do minus the 41.79 first. Giving me 48.21. And I'll subtract the 16.73. Giving me 31.48 degrees. What do you think? Good stuff? So I realize there's a problem where finding the appropriate triangles not so simple. That's why I tell you, the tough part is getting the triangle. Once you've got the triangles, finding the missing parts is relatively easy. Finding the triangles that are necessary to solve the problem is the tough part. Well, since we're working on that general theme, let's go to another example. This example is actually out of your packet. It's on page 371, number 23. I've taken to doing this example in class every year because it's one that students almost never get on their own. And they almost always... Anyway, so we're just going to go ahead and do it so you can see how it's done. And to be totally honest, this is one that the first couple of times I did it in front of the class, you know, sometimes you try a triangle, it doesn't give you the information you need, so you have to go back and start all over. Yeah, there's a couple of times I've had to go back and do it 2 or 3 times before I came up with the right triangles to make it work. So just a warning, we'll see if I can get it on the first try this time. It's been a year since I've done it. Actually, to be honest, last spring we were online, so I didn't have to do this problem in front of the class. So the big change here is that our V does not have, is not either oriented vertically or does not have one side that's either vertical or horizontal. Both sides of the V are angled, but at different angles. This side over here is 2.420 inches. This is 0.325 inches. Down here it is 3.120 inches. That dimension, 0.00. Diameter of our piece of round stock, 0.925 inches. And then we need to know this angle right here is 69 degrees 17. And this angle right here, 7 degrees 36 minutes. Want to find this dimension y right here. How far is it from the bottom of the part up to the top of the round stock? Now, at first glance, this does not look too much more difficult than our standard B-block problem. But first thing is that there's some missing dimension. So let's find some of those missing dimensions. To do that, I'm going to start out. We don't want to start out on this side. I draw a right triangle in here. I was going to draw a right triangle in over here, but I don't have this dimension, so I can't find the bottom of that right triangle. Over here, however, I do have that this is the 0.325, and this is 0.200, 2.000. So I can find this dimension by doing what? .12 minus 2.000 minus 0.325. What is that? 0.895, is that right? I'm sure just suddenly popped off the wheel for something. It is 0.795. Double checked. 0.795 inches. I am going to redraw this light blue triangle. .795 inches. Do I know this angle here? Right. This is a horizontal. This is a horizontal. All horizontals have to be parallel with each other. So if they're parallel, this angle and this angle, the same. The part of this that I want to find, right over here, I'll label it A. The reason I want to find A is not because knowing A does me any good. What I really want to know is the distance from the bottom of the V down to the bottom of the part. I said I could have done that over here if I could have found this dimension, but because I didn't have the pieces needed to find the bottom of that triangle, that wasn't going to work. So to find A is what side according to our angle? Opposite. And I have the 0.795, which is the adjacent. So we are dealing with a tangent. So we know the angle, so we'll put it in. Tangent of 69 degrees, 17. The opposite side is side A, that's what we're looking for. Over our adjacent side of 0.795. To solve this, I make it a proportion by putting it over 1. Whenever I'm missing a side, that's what I do, is I turn it into a portion. Proportion, so I can cross multiply and divide. It's going to be the tangent. 9, mark that as degrees. And again, that's times 0.795, and we don't really need to divide by 1. Right, 2.102. So this is 2.102 inches. This height here to the bottom of my V, 0.42 minus 2.102, 4.318 inches. Now, to find y, I need that dimension. But I also need the height from the bottom of the V up to the center of that round stock. And then I already do have this here is going to be the radius. I'm going to draw that over here. Radius is just going to be half of the 0.925, right? 4625. All I need to find is this piece from the bottom of the V up to the center of the circle. Anybody seeing it? There's an obvious right triangle there. You have the circle, the radius of the circle to the tangent. That's over here. Could have done it on the other side, but I'm going to do it on this side. Here's my right angle. I know a side of that triangle. This side here is the radius of the circle, 4625 inches. But I don't know any angles. Find some. Well, if I extend this side here up like this, it's over there, right? This is 6917. This, since this is horizontal and this is horizontal, they're parallel. This angle here is still 2746. So this angle down here has to add up to 180 with those two. I'm going to do 917 plus 2746. Gives me 97.03 degrees. Does that look right? I have to subtract that from 180 to get this angle. (97 degrees, 3 minutes). Subtracted from 180. I borrow, this will be 179, this will be 60. 7 minutes, and now that is this whole angle down here, right? This angle is found by cutting that in half, connecting the center of the circle to that intersection of tangents. Cuts that angle in half. So we have to divide that by 2. 82 divided by 2 is 41. 57 divided by 2 is 28.5, so that's 28 minutes, 30 seconds. Now we're ready to find whatever missing sides here that we want to find. Side that's going to be helpful to us, this side right here. Which side, according to our angle, is that? The hypotenuse. We have that radius over there, the 0.4625. That would be the opposite side. It's across our angle. Doesn't touch our angle. So opposite hypotenuse make pi. Sine of an angle is the opposite side over the hypotenuse. So we know our angle is 41 degrees, 28 minutes, 30 seconds. The opposite side is 0.4625. The hypotenuse. Since we're looking for a side, we'll turn this into a proportion. Put the trig function over 1. And we'll cross multiply and divide here. So 1 times 0.4625 is 0.4625. Divided by the tangent of 41 degrees, 28 minutes. This should be sine. You are correct. 0.4625 divided by the sine, 41 degrees. Seconds. 0.698 we get. That was this hypotenuse here. That's this right here. The question is, how does that help us? Well, we need to find vertical distance, this distance. So let's create a right triangle with that vertical distance in it, vertical dimension. That right triangle looks like this. The only thing we know of that right triangle is that this hypotenuse, okay, we need an angle here of some sort. I'm going to do, this is where I chuckle because I totally get why students ask me to do this one every year. Because I sure hope I'm going in the right direction because I'm doing a lot of crap here. It'd be a lot of work to go to waste. I think I've got it. I believe we're going to look at this triangle right here. That blue triangle kind of fits over the top of this one. This angle over here is still the 69.17. That's because this is horizontal, so it's still that 69.17. And the angle down here, this one we had up here, the 41.2830. So I can combine 917 with 41. Adding there, of course. 110 degrees, 45 minutes, 30 seconds. To get this angle up here, I'll subtract from 180. I should borrow from the 180, makes that 179. This becomes 60. Borrow from the 60 to make that 59. This becomes. Now I subtract. I've got 30, 14, and 9. This angle up here is 69 degrees, 14 minutes and 30 seconds. Back to my red triangle over here. .698 inches is the hypotenuse. There's my right angle. This angle is that 69 degrees, 14 minutes, 30 seconds. Now, we're ready to find that simple little hypotenuse. So according to our angle, the missing height there, which I'm calling B, is which side? The opposite. 0.698 is the hypotenuse. So we're dealing with and again. So I fill in, sine of my angle is 69, 14, 30. My opposite side is what I'm looking for. My hypotenuse is 0.698. Now cross multiply and divide. So sine of 69 degrees, 14 minutes, 30 seconds, times 0.698. I don't have to divide by 1. I get 0.653. Coming up here, this dimension is 0.653. I just add those three up to get y. At 1.4335 inches. See, that wasn't so bad. So, I'm serious now. How many of you'd rather not see a problem like that on a quiz?
Get lost.
So, make checks payable. Todd Huff, retirement. I actually said that on recording 2 times. we may have to edit this recording. Well,
I heard nothing.
In the packet, it is page 368 through 371. Problems. Well, we just did 23, so we'll make it 1 through 21 the odd. And yes, these are the tough ones. From here, we're going to shift gears a little bit. We're going to go back through some of our reference angles and stuff like that. We're going to do a little bit of that. And next week, we're going to talk about triangles with no right angles. Oblique triangles. A lot of sines, a lot of cosines. Hopefully finishing this unit up by the end of the day next Wednesday, so that next Thursday, you guys can. Actually, you guys are in class. So remind me on Wednesday that I'll make sure I have the test sitting out for you. Okay, well, we got a little time to get started on this. So.